Electron beam machining. The working principle of electron beam machining is when high velocity of electron beams are focused and concentrated on a small spot on the working piece, and the kinetic energy of the electron is converted into heat energy, which is sufficient to melt the workpiece. Now we're talking about the setup of a EBM or the electron beam machining. The first one, the electron gun. Electron gun is to consist of cathode, a grid cup, and an anode. And a cathode is a tungsten filament which is heated by a low voltage current. And the second setup is a magnetic lens, which is magnetic lens is further converges the beam into a narrow spot on the workpiece. And the third setup is the magnetic deflection coil. Magnetic deflection coil or a beam deflection coil is used to deflect the beam further either onto a different spots on the workpiece or for moving it along the contour of the workpiece. And the fourth setup is a movable table. A table which is used to mount the workpiece is kept within the vacuum chamber, which is you see in the bottom of the system. And the table is controlled numerically to move under the beam. And also, the machining of a workpiece is done by moving the table or by deflecting the beam. Setup number five is monitoring system or optical viewing system. A light microscope is kept to monitor the complete process, and the operator can adjust the position of the workpiece as per requirement and observe the actual machining process. So the microscope is can be adjusted by the operator itself. And the last one is the chamber, which is this process is carried out by prevent collision of electrons with gas molecules, and it prevent to scattering the beams all over the place. So pretty much the vacuum chamber, it's the whole system itself is to prevent the scattering beams all over the place. It's only to focus on a specific spot on the electron beam machining.
Now we're going to take a look at the safety concerns for electron beam machining so you make sure everything can go smoothly and it works properly. So the first thing you need to consider is making sure that the machine is properly cleaned. Making sure that it's properly cleaned makes it so that it runs smoothly, nothing breaks down during it, and just overall nothing goes wrong during it. The next thing you need to make sure to do is make sure that the vacuum chamber works properly. Vacuum chamber is one of the most important parts of electron beam machining. It allows it to take all the gas particles out of the machine and move it somewhere else. So you got to make sure the vacuum chamber works properly. The next thing you do is you need to make sure that you keep the heat within the machine. During this electron beam machining process, the temperatures in the machine can get to upwards of 250 degrees Fahrenheit. It gets very hot. So you need to make sure that the heat is contained and that nothing is getting out of the machine so it works properly, so it doesn't malfunction or anything. And the next thing you need is a stable current throughout the system. Stable current allows it so that you can have a high voltage source through it and make sure it's stable so the whole machine can function properly, making sure it doesn't overheat, it doesn't underheat, you get the right temperatures you need, make sure it works properly. So having a stable current source allows you to make machining a whole lot easier and make it run properly.
All right, after we've gone over the specific components of electron beam machining, now we're going to go a little deeper into the specific process that this tool goes into. The first thing that you want to do when electron beam machining is to upload a program of your requested design into the machine. So it'll be very specific and accurate in how it moves your workpiece within the chamber. And then the second thing is you want to load your workpiece into the chamber. After you've uploaded the program of what you want the beam to cut away, now you're putting it into the chamber. And these two steps don't take a lot of time. The setup for this is pretty quick. However, the majority of the time is taken having the vacuum seal be accurate and appropriate. Like we talked about before, if the vacuum seal is not appropriate, then it'll cause the beam to deflect in ways that we weren't wanting. But after we let the vacuum seal completely, then we put in our specifications of the material and the shape that we have in the chamber into the machine, and then we let the machine start working. The electron beam will start to cut away at the workpiece in the specified design that you put in. And what's cool about this is that the way the electron beam works to cut away at the workpiece is actually produces localized heat in specific areas, which means it's very accurate. It doesn't disperse the heat over a large area. It's very accurate as the localized heat, and it causes the surface material of your workpiece to evaporate. And this will produce a very, very clean and accurate surface finish, so we can achieve high tolerances through this type of machining. This is used for cutting, profiling, slotting, and surface hardening, this type of machining. And also, the way that the electron beam functions is with pulses. It'll send out specific pulses of different widths and times to achieve very accurate hole depths and diameters. So saying all this, there's several benefits that this type of machining provides us. One of the great benefits is that there's no moving mechanical parts, and this will allow us to be able to machine on very thin and maybe fragile surfaces. So we can still, like a lot of times, this will be used for engraving or in larger industrial companies will use it for making fiberglass, where those cylinders that have very detailed holes. So the no mechanical moving parts allows us to be able to manufacture on very thin and maybe fragile surfaces. There's also a much higher productivity at a lower cost. Because it's so accurate and detailed, you can combine a whole bunch of small manufactured parts into one big block of parts, and it'll cut away very accurately. And just discussing the cost a little bit, there's the tooling cost is very high. However, it lasts for quite a while, so that's over an extended period of time. The other big negative with cost is the labor. You need a very skilled person to put in the correct programming and load everything incorrectly. However, where we save a lot of money in this type of machining is the low finishing cost, which a lot of other types of machining have a much higher finishing cost. However, because this is so accurate and gives us a clean surface finish, then that is much lower.